2.4 billion golden satisfiers of American desires. This is how Harry Weinberger of the Banana Buyers Association described Gros Michel. No, that's not how I describe my ex-wife. It's a banana cultivar known in English as Big Mike. Big Mike was the premier banana of the late 1800s to early 1900s, and is a different banana than what you know and love today. Even so, history is repeating itself. The fungus that killed Big Mike has come back with a vengeance, killing its Cavendish cousins in much the same manner. My name is Clancy here at Crater Alias, and today we'll be talking about the banana's history of bananas, I know, low-hanging fruit, and how we're fighting the return of Fusarium today.
Bananas.
Now, I did a lot of reading for this video, and by gum, banana's history is complicated, so I'll keep it condensed. There are two important groups of banana, the Australomusa and Eumusa. The Australomusa is older, with evidence of cultivation dating back as far as 5000 BC, but the Eumusa is where bananas really started taking off. Around 3500 BC, efforts to cultivate the Eumusa varieties turned into the edible progenitor AA banana. Now, these ancient bananas sucked. They had a lot of seeds, they weren't as sweet or as big, but they grew very easily. And if you're an ancient man, you could sustain yourself even if you had to pick through all these seeds. The general origin of these banana cultivars started in Papua New Guinea, then Indonesia, then Southeast Asia and Greater Asia. Sometimes this flow started in Southeast Asia, but that's because there are a lot of banana cultivars. But how did Eumusa seeds disappear? Two things had to happen: parthenocarpy and sterilization. Usually, pollen is required to trigger an ovule to turn into a fruit, but parthenocarpy is the process by which this happens without pollen. Here is a pollinated banana for reference, and the like and subscribe button. Whoa! No, seriously, like and subscribe. I appreciate it. Parthenocarpy means that seed production is reduced or almost eliminated. This is actually the process that gets us seedless watermelons. But in bananas, this still leaves some seeds. In comes our second word, sterilization. Taking things one step further, bananas produce things called suckers, offshoots of the main rhizome, which act as a sort of asexual reproduction. Given time, mutations in these suckers accumulate, making seeds less and less common. Given 5,000 years, and suddenly, all the bananas are sterile. 5,000 years, no more, no less. What this means today is that we can't use seeds to spread banana. We have to use these suckers, meaning all individuals of a strain are nearly genetically identical. This happened to the progenitor edible AA banana and has continued today with our AAA and AAB bananas, which we in the West respectively call bananas and plantains. TLDR, bananas are super old. They used to have seeds, but now they don't. They taste a lot better, but this comes at the cost of having monoculture fields where everything is genetically identical. This has worked out great for banana production, but has had some hiccups, to say the least. Finally, to the man of the hour, Big Mike. Mike's story starts with Nicholas Bodine, an explorer in the latter half of the 1700s, best known for exploring the southern and western coasts of Australia. He's credited for bringing the Big Mike banana from Southeast Asia to the Caribbean, but I couldn't find much proof for this. There were a lot of people saying, oh, he brought it, but there weren't really a lot of citations other than Wikipedia, and while Wikipedia is a great resource, it is not a source. No matter, I go to my school's research paper finder thing, searched up Gros Michel and history, and of course that brought up Confessions of the Flesh, The History of Sexuality, Volume 4? I of course set that aside later while I continue digging. I eventually found a book on Nick, carried by the spirit of the times, The Voyages of Captain Bodine. A perfect source that details all of Nicolas Bodine's travels, and a perfect source, and oh, did I mention it's in French? Je peux comprendre un petit peu de français, mais c'est un défi différent. There's no mention of bananas in the book, but there's a couple of things that make me a bit skeptical on if Nicholas was the harbinger of Big Mike. He was in Asia in 1788, but didn't make it to Martinique until 1790. Since these bananas didn't have seeds, he would have had to bring suckers or corms. Banana rhizome lifespan is something I couldn't find much info on because of all these damn AI websites, but surviving 2 years in unoptimal conditions, it seems fishy to me. I find it just as likely that other French naturalists George Scholl, Franz Boas, Antoine de Jussieu, who all had tropical plant species that were brought to the Caribbean to be the actual finder of Big Mike. But Nicolas Bodin may have actually brought these specimens with him in 1790, 1797, or perhaps another captain who I couldn't find in my research. Now, for a video about fungi, I sure am not talking about fungi a lot.
Get on with it!
But just a bit longer, I promise. We do know the man who popularized the banana, Jean-Francois Pouillat, who brought the banana from Martinique to Jamaica in 1837. While the less known names, Pollo and Bodin's fig, can be explained, the name Gros Michel seems to have erupted spontaneously in etymological history. Now, I don't know if you know anything about the 1800s, but there is this thing called slavery. While Jamaica abolished slavery in 1833, the exploitation did not end there. The banana republics expanded through monopolizing and taking advantage of the poor. This continues in part today with union busting, and while conditions have improved, they're by no means perfect. Big Mike's rise was accompanied by slavery and exploitation, and it's important to note that here. Big Mike reached the Americas with the advent of refrigeration, from a wholesale value of $250,000 in 1871 to $6.5 million in 1901, doubled by 1911. People say Big Mike was even sweeter than today's bananas, and as more and more gained a taste for Mike, production skyrocketed. Acres and acres were cleared, literally becoming uncountable due to the intercropping of cacao and coffee. A conservative estimate is a few million acres. Bananas became a symbol in American culture. Littering of banana peels was so prevalent that it became a comedy bit, something that is lost on us because Big Mike's peels were thicker and thus more slippery. Popularized in 1910 by comedian Billy Watson, the bit quickly made its way to the big screen in silent films The Flirt in 1917 and The High Sign in 1921. Bananas became a staple in art beyond your standard bowl of fruit study. The Meal by Paul Gauguin depicts the traditional use of bananas as a local source of food, especially in these tropical and subtropical climates. The painting, The Uncertainty of the Poet, took the banana and turned it into a still life, maybe with some other connotations? Whoa, censor that. Bananas continue to have influence on pop culture, from Super Monkey Ball to Andy Warhol, from Holla Back Girl to Yes We Have No Banana, from Peanut Butter Jelly Time to the Banane, and whatever this is. What's this fungus doing here? Finally, we can talk about fungus. I know this is something of a funeral, but please like and subscribe. I was blown away by the support from the last video, and it really means the most. Also, video game fungus, next time. The Last of Us is a long game. Big Mike fell victim to a fungus, Fusarium oxysporum forma specialis cubense. Race 1. Mouthful, I know. Whole nother video about fungal nomenclature. Don't worry about it. This Fusarium causes plants to wilt. And while Fusarium wilt is a general phenomena found in many plants, the one that affected banana earned its own name through banana-y blood, Panama disease. Once again, I had to turn to the literature, but fortunately this time it wasn't in French. Woohoo. Now this book here is where I got a majority of my information on Panama disease's history, so if it's not down there, then it's from right here. So, Panama disease. It was first reported in Australia in 1857, though it likely originated in Malaysia the country, or South Asia, the subcontinent? Yeah, let's go with that. The running theory is that the former dominant banana variety, Silk, likely had some sort of similar Fusarium wilt that was the great-great-great-grandfather of Race 1 Fusarium. Jamaica was likely the first country to have Panama disease, but it was quickly followed by every other country in South America and even spreading to the Pacific Islands due to the exporting of suckers. Race 1 not only targeted Big Mike, but also Silk, Kathali, and Marthamon bananas, particularly Marthamon, which neared extinction. This wide host range made tracking kind of tricky, but one thing was for certain. The death of these other cultivars was a sign that nearby Mikes would drop. Fusarium enters the plant casually. Once a spore germinates, it will attempt to find a host, and once it detects one, it will react. Hyphae will grow into microscopic roots, usually from where lateral roots emerge, and once it detects that it's inside, it'll turn hostile. Fusarium's enzymes will break down the surrounding tissue, allowing it to grow deeper and deeper into roots until it reaches the center, the vascular tissue. Once there, it can spread up and down the vascular tissue and block water transport. Now, sometimes Fusarium will attack the main rhizome, but usually it's through these lateral roots where most of the damage occurs. The lack of water is what causes eventual wilt and death. To add insult to injury, Fusarium will release massive amounts of spores into vascular tissue, which will make their way up the plant and out of plant stomata, further increasing spreading capability. While normal spread of Fusarium is limited to just a couple of feet, this is because aerial dispersal is possible but not effective, spores can spread through a variety of other methods, such as infected suckers, contaminated equipment, or, this is a big one, water. Flooding causes spores to spread into rivers, basins, and onto uninfected banana farms. Now, banana trees are big, and the fungus is slow, often taking years to eventually kill a mature plant. But unlike many of our annual crops, which don't care about some disease that'll kill them in 10 years, Fusarium makes bananas' long lifespan a detriment. Mature plants can endure, but the less hardy suckers can't get a foothold in contaminated soil. Fusarium is a slow killer, but a relentless one that leaves soils barren, unfit for future bananas. So, Panama disease is deadly to bananas, able to spread relatively quickly, and bananas are a crop we care about, so why haven't we fixed it? Fusarium and other pathogens, plant, human, or otherwise, are incredibly hard to kill when they're in the environment. Standard cultural methods work, but only a little. Increasing pH through the addition of lime or altering the soil through the addition of clay were the main two methods. The go-to was to cut up infected plants and dump lime on them, but these were temporary fixes. They didn't actually kill the Fusarium. In order to contain Panama disease, the Jamaican government enacted laws that required the reporting of Panama disease and detailed quarantine procedures. Great idea, right? Well, this is how those laws usually ended up working out. Hey there, I'm a government person, and I'm here to talk to you about Panama disease. Since you're a banana farmer and it affects bananas, we want to make sure that you know about it. So if you see these signs, let us know. Oh, that's good to know. So you're going to fix it? No, we'll get rid of it. We'll take any plants within a 16-foot by 16-foot square of an infected plant, chop it up, and then burn all of them, then cover it with lime to make sure that it doesn't spread. What? That's like a lot of bananas. That could be my livelihood you're messing with. Oh, also, we're just government people, not scientists or anything. We'll probably get rid of most of your banana plants and then still spread the disease, even though we're trying to get rid of it. What? How long is this going to go on for? When am I going to be able to produce bananas safely again? Oh, don't worry about it. In a couple of years, we'll reduce it to an 8-foot by 8-foot square, and instead of burning stuff, we'll just chop it up and cover it with lime. So what do I get for complying? You don't go to jail. Okay, well, that's great. I'm going to start growing sugarcane now. And on an unrelated note, I'm going to throw these plants that definitely don't have Panama disease into the river. Sure thing, bud. Remember how I said floods and other sources of water were really good for spreading Fusarium? Yeah. The 16-foot by 16-foot square was also somewhat arbitrary. You could clear an entire field and not get rid of Fusarium. This is because Fusarium can survive in the soil basically indefinitely, either as a saprophyte or through hardy chlamydospores. The cultural methods that slow Fusarium are fantastic compared to the biological methods. Big Mike had some friends, some insects, some other fungi, some bacteria, which were either fungistatic or fungicidal, but nothing really that could kill Fusarium. Chemical methods especially don't work. It's silent spring on steroids. Fungi like Fusarium will grow an extra chromosome just for shits and giggles, and even if you kill a billion, 1 out of trillions or quadrillions need to survive for the whole cycle to repeat again. Alongside these aneuploidies, a likely parasexual cycle further complicates things, allowing Fusarium to mate with other fungal species like Nectria. Various other methods were also attempted, blending insect carcasses, high applications of dextrose, even chemotherapy, but nothing was significant enough. Big Mike's death was a slow one. It's still even grown in some areas in small quantities, but not nearly enough numbers for us to produce it consistently. The death of Big Mike plantations cost over $2.3 billion in estimated damages. With all methods exhausted after 30 years of study, the best option was to replace Big Mike. This book puts it very succinctly in the last sentence of it. The use of resistant varieties provides the only solution. So Big Mike is dead, and while we all mourn his passing, not to worry, as the Cavendish are here. The Cavendish varieties started to take over in the 50s, but completely monopolized the banana business by the 60s due to the loss of Big Mike's profitability. But why are the Cavendish varieties resistant to race 1 Fusarium? All plants produce root exudates, a slurry of molecules which we're still trying to fully understand. Different exudates from different plants inhibit different microbes. The Cavendish variety exudates are particularly anti-Fusarium, whereas Big Mike's might have actually facilitated the growth of Fusarium. Cavendish varieties also seem to have increased immune sensitivity, which allows for defense in the form of tylosis. Swelled root cells cut off vascular tissue, allowing active defense systems to come in and kill any pathogens. Given their resistance, they grew extremely well, even in the presence of race 1 Fusarium. Despite their thinner skin and inferior flavor, Cavendish was the obvious replacement for Big Mike. So the day is saved. We'll have bananas forever and ever, and nothing will ever... Oh, what's that? The exact same fungus? I'm crazy and nobody's on the phone? Yep, that's right. Panama disease is back. And we're going back to the first plantation to get Fusarium off the menu. This new Fusarium, dubbed Race 4, is particularly scary in that it affects 80% of all bananas grown today. We first identified Race 4 in 1990s Taiwan, with suspected origins in, who would have guessed it,
Malaysia. I meant Malaysia.
We then saw it in Australia in 1997, Mozambique in 2013, and has finally made its way to Central America through Colombia in 2019. It's essentially the same issue that affected Big Mike. Fusarium kills Cavendish by the same mechanism and prevents Cavendish bananas from being replanted because it does the same thing in the soil. While we have better quarantine technology, things like globalization or global warming could have actually aided in the spread of Fusarium. The fall of Big Mike was huge, but the fall of Cavendish will be bigger. We grow a lot more bananas today than we did 50 years ago. A lot more. This will be especially true in Africa and Asia, where Cavendish aren't the sole banana. More hosts and higher economic significance, both as an export and a local food source, makes Race 4 more significant. So what's the plan? Well, it's been 60 years and we've learned a thing or two. Oh, I'm doing research? The primary way we're dealing with Panama disease is to stop spreading it. Yeah, no sh. Many large banana farms don't allow visitors. People in trucks who have to be there are sprayed down with fungicide, and all suckers are inspected to make sure they're Panama disease free. Research has also improved, but hasn't been as actionable unless we, give all the Fusarium a susceptibility gene, which, good luck with that. It's good work, but it's not really that actionable. The next thing we're doing is finding new bananas. While this is what we did last time, we have better technology like GMOs and greater globalization that allows us to find and test more banana species for resistance. Initial testing and breeding for Panama disease resistance started way long ago in the 1920s. Programs in Honduras and Brazil aimed to find alternatives to Big Mike and Silk banana varieties respectively. Even though Big Mike was soon to be gone, there was resistance in picking up the Cavendish varieties, simply because they weren't Big Mike. Same idea for the Cavendish. It'll take more than just a silly extinction level threat in order to change our banana species. We need a good alternative. Our new banana cultivar has to grow well, taste good, have a nice peel for shipping, and have no seeds. This started with breeding efforts. We found some AA and quadruple A bananas which ticked some of the boxes, but these were thrown away relatively quickly as GMOs swiftly took their place. Genes related to apoptosis or immune defense have been reported as targets for alteration, but much of the work is privatized, so we don't know exactly what work's been done. Whether these efforts bore fruit is ambiguous. Speaking of boring fruit, the best fruit! Chiquita revealed their new yellow A banana in September of last year that they claim is not only resistant to race 4 Fusarium, but another banana disease, black sigatoka. Unfortunately, I can't tell you exactly how they did this because all the information is proprietary. Damn it. It was most likely made through a combination of hybridization and gene editing, as they worked with the company Keygene. They aim to not only produce yellow A bananas, but at least 2 more resistant varieties with more to come. Perhaps the future of the banana will continue this way, with us having to find a new cultivar in order to combat a new pathogen, perhaps Fusarium once again. Maybe we'll find the perfect banana that is immune to all pathogens, but more likely than not, every 50 years we're going to have to find a new banana. A sustainable option that I'm a fan of is trying other kinds of banana. Try the small red ones or some plantains if you can find them at your grocery store. If there's one thing that bananas have taught me, it's to not trust the front. It's that what's on the inside is what counts. Finishing up this video, I wanted to point to some other resources that I found incredibly helpful while making this video. First off is ProMusa. They're a group that are dedicated to the research of bananas, and they make a Wikipedia-esque site in order to help communicate information on bananas and plantains. We also have these YouTube videos, which were really interesting and cover things that I don't really cover here. Slipping on bananas, banana republics, and the history and transport of bananas, especially to Africa. They're all great. Check them out. Thanks again for watching. One last reminder to like and subscribe. Have a good one.